All right, so let us quickly solve this Olympiad mass integral problem. Okay, so now we are asked to integrate this function, but this will take us to a gamma function. So you should remember, or you should recall that the gamma function of any function x, okay, the gamma function of any function x is equal to what? The integral from 0 to infinity of t raised to power x minus 1, okay, then e raised power minus t dt, okay. So you should remember this particular formula, okay. Now the question is, the question is from 0 to, the integral is from 0 to 1, but this one is that the integral is from 0 to infinity. And in the formula I have exponential while I don't have exponential here. So let us use the substitution method to know if we can make this to look in this form. Once you can be able to turn this to look like this, then you are done and the answer is there. So now what do? Let's say that let t be equal to that lane x, sorry, lane 1 over x, okay. So let us take the exponential of both sides. So I have the exponential of t is equal to exponential lane 1 over x, right? Don't forget that exponential is opposite of lane, so they can cancel out. So therefore e raised power t will now be equal to what? 1 over x. Now this could be written over 1, so if we flip this one, take the reciprocal of both sides. So that is 1 over e raised power t is equal to what? X, okay. So now according to indices, x now is equal to what? E raised power minus t. Now from here we can get the derivative of both sides. Let us differentiate both sides. We have that the x will now be what? Minus e raised power minus t dt, okay. So don't forget that in differentiating this thing, differentiation of x will give you the x. Now differentiating this thing will give you, differentiate the top to give you minus 1. Minus 1 times differentiation of everything. And differentiation of e raised power something is same thing as e raised power that thing, okay. So that's how we have minus e raised power that thing, because the differentiation of this minus t gave us minus. We multiply it by the differentiation of everything. That is a chain rule of differentiation, okay. So now we are getting closer to what we have. So what do we do now? The problem now is that our own integral, we have gotten most of the things we need, but the only problem we have is that our own integral started from 0 to infinity, while their own started from 0 to 1, while their own started from 0 to infinity. So now let us see what we are going to do here. Now, from this place, let us see what we are going to have. Let us substitute x to be 0, okay, and see what we are going to have. When x is 0, when x is equal to 0, let's see what we are going to have if x is equal to 0 here, okay. Now if x is equal to 0, we are going to have that, in fact, this thing is the same thing as saying x, this is the same thing as saying x is equal to like here, okay. Let's do it here. Now when x is equal to 0, we now have that what? 1 over e raised to power something. In fact, what do you do here so that you can get 0? The only thing we can do here to get 0 is that by putting this to be infinity, because look at that. When x is 0, we have that 1 over e raised to power t is equal to 0, right? When x is 0. So now if there is change, let's assume there is change. E raised to power t is equal to what? 1 over what? 0. And 1 over 0 is infinity. So, and e raised to power, the only thing that will make this place infinity is infinity. So therefore, when t is 0 and when x is 0, our t is what? Infinity. Okay, you should know that. Now the next thing is that when t is 1, we have checked when t is 0. Now when t is 1, what are we going to get? When t is 1, when t is equal to 1, let's see what we are going to have. Sorry, when x is equal to 1, not t. When x is equal to 1. So let us put it here again. Let us put it here. I have that 1 over e raised to power t is equal to what? 1, okay. So this is what? E raised to power minus t is equal to what? E raised to power 0, right? So what does it have? What do we have? We have that t is equal to 0. So it implies that when x is 1, then t is equal to 0, okay. Now having this, we can now rewrite this thing now to now be the integral. Don't forget that when x is 0, t was infinity, and when x was 1, t was 0, okay. Then this is now, we call this t, we call this one t. This is now the square root of t, all right? Then we got the t as minus e raised to power minus t dt, all right? Okay, so dt. Now the problem now is, permit me to clean here. Okay, now the little issue we have is that okay, this could be written as, let us bring this minus outside. This is minus the integral from infinity to 0 of t raised to power square root means raised to power 1 over 2. Okay, raised to power 1 over 2, then e raised to power minus t dt. Okay, now we are getting closer to our gamma function, so don't forget that let me write it here. Oh god, oh, sorry. So don't forget that the gamma function of x, okay, is equal to the integral from 0 to infinity of t raised to power x minus 1, then e raised to power what? Minus t dt. Okay, so we're getting closer to this. This is now trying to look at it. The problem we have that this started from 0 to infinity, while our own started from infinity to 0. So to swap it is just to put minus. So I have this minus that is already here. Now for me to swap this thing is going to be minus the integral from 0 to infinity of what? T raised to power half, then e raised to power minus t, then dt. Okay, so now if minus multiply minus, then they are gone. It becomes positive. So I'm now left with what? The integral from 0 to infinity of t raised to power 1 over 2, then e raised to power minus t dt. Okay, now if you compare this to this, you'll be seeing that if you compare both of them, we are going to have that that x minus 1 is equal to, look at that, we're going to have that x minus 1 is equal to half. Okay, so therefore my x is equal to what? 1 plus 1 over 2. Okay, now but don't forget that the gamma function of half, sorry, not square root, but gamma function, the gamma function of half is equal to square root of pi. Okay, so please don't forget that the gamma function of half is the square root of pi. So don't forget that we still have this. So this thing now could be written as, I hope you know that this thing could be written as the gamma function of our x is 1 plus 2. Okay, so it's going to be the gamma function of 1 plus half. Sorry, 1 plus half. Okay, I hope you are getting what I'm doing. Look at it. We have that that we compare this to this so that we can get what x is, and we got x to be 1 plus half. So we are using it as the gamma. So everything here is something as, look at what I'm trying to say, that the integral from 0 to 1 of the square root of ln 1 over x, okay, the x is the same as saying the integral from 0 to infinity of t raised to power 1 over 2 e raised to power minus t dt, which is same as the gamma function of 1 plus half. Okay, now but you need to know again that the gamma function of 1 plus x, okay, is equal to what? X, the gamma function of x. Okay, please record this, very, very important. So this is now the gamma function, not square root, sorry, gamma function. So the gamma function of 1 plus half is the same as saying half the gamma function of half. Okay, and then don't forget that I told that the gamma function, sorry, that the gamma function of half, not square root, the gamma function of half is what? Is pi. So this is now equal to what? 1 over 2 square root of pi. Okay, which is what? The square root of pi over 2. So the solution to this is what? Square root of pi over 2. I hope you understood it. So this is the concept of gamma function. So this is 1 over 2, sorry, square root of pi over 2. So thank you very much for watching. Please don't forget to like this video and subscribe.